Hello, sir.
Hi Muskan.
How are you?
I am good. It's been a long, long time.
Yeah, it has.
How did you write
Very
the
long. I think
exams?
the exams, they were good. They were good. They weren't too
Okay.
bad. And then after that, we had like AST, which was like another really big exam, which we can't study for. So I was like exhausted after that. And then assignment week started just
So
today.
when will be your next exams?
I've got another chemistry exam coming up after the school holidays. I think it's the third day back.
And
They
when do the
haven't
holidays
released.
start from?
So next week is the last week of this
Okay.
term, and then we have 2 weeks holiday, and then the first week back we've got chemistry exam.
Oh.
So
So
I'll
now
probably have to
what
study
you're
during.
okay. So now what you're learning is plastics and polymers in school, right? I mean college.
Yeah, I think so.
So they still haven't started that.
No, actually, they haven't like I don't know. Our teachers kind of lacked ever since we finished our exams. We've watched like she's focused on like the substitution, etc.
Hmm.
Yeah, substitution, addition, and subtraction.
Reactions.
Yep, that.
So they didn't teach you polymers yet?
Pardon?
They, haven't they taught you about polymers?
Yeah, so we recently just watched a video, like last lesson. So it
So
was on
first
Monday that we watched a video on polymers.
So first, let me start about polymers, and then we'll go to the reactions. Okay,
Okay.
substitution, addition, and subtraction.
Okay.
First, let us start plastics.
I don't know
So
what we're going to do with plastics. And then we have like an assignment as well.
yeah,
We're going to do like an individual experiment. Let me I honestly don't get the assignment, not gonna lie. Like I see more of a biochemistry than organic chemistry with that. But yeah, so the test is on October 13th.
okay, that's next month. Okay, fine.
So exactly in a month.
What is it about?
The test,
Yes.
I couldn't tell you because they haven't put anything up.
Acha, okay, they only just announced the date of the exam.
Yeah, actually, I just found out today that we have an actual exam coming up. I thought we would have our the independent project that we're doing,
Okay,
but we are not.
so let us start with plastics first. Okay, so what exactly are plastics? What is its composition? And then we shall move on to polymers.
Yeah.
Okay, so basically, plastic is a kind of material that contains essential ingredients, an organic
Mm-hmm.
substance of a larger molecular weight. So
Yeah.
basically, it can be defined as polymers of long carbon chains. So
Plastics.
when
That's what
yeah,
plastics
yes,
are.
so when we define plastics, then can be called as defined as polymers of long carbon chains. Understood? So that's the reason we have this topic plastics and polymers going in tandem, going together. Okay. So basically, the word when you say plastics, okay, it comes from the Greek word plastikos, which means mold. Because most of the plastics that we use in our daily life or day to day life, they're all molded forms of plastic.
Yeah.
Yeah, isn't it?
Yes.
So, where does,
We. Yeah.
yes. So basically, when you say plastics, we call them as polymers and nothing. Polymers are nothing but again they're long form chains of hydrogen and carbon. Okay, so
Yeah.
when you talk about fossil fuels, they as well have compounds containing hydrogen and carbon, and these hydrogen and carbon act as building blocks for these long polymer molecules. Okay,
Yeah.
so basically these building blocks can be called as monomers. Okay, single. Okay, and when we link together to form a long carbon chain, then these are called as polymers. Okay,
Yes.
that basically that's the difference. Okay, so if I now jump onto polymers directly, So what can be
There's
said?
thermoplastic and then there's thermosetting, right?
Yeah, absolutely. Now, when you say thermoplastics, the word means heating.
So it can
Okay.
reshape and become
Yes,
plastic again
and
and soften.
exactly. So plastics that can be deformed, deformed is which
Okay.
can be transformed into any shape upon heating, and which can be bent easily. So those kinds of plastics are called as thermoplastics. So basically, it is heated and then it can be formed or deformed in a shape that we require.
Yeah.
Like for example, if you talk about polyethylene,
Mm-hmm.
okay, a plastic bag, for example, a nylon thread, these are all
Oh, we made
thermoplastics.
nylon.
Yes,
Yeah.
even nylon as well. So that is thermoplastic. Now, when I say thermosetting plastic, it's quite different from the first one. So here, the basic difference between thermoplastic and thermosetting is in thermoplastic they are quite soft. Okay, it can be softened again and again, but
Mhm.
thermosetting plastics that cannot be softened again by
And
heating
don't they
once you
gain
mold it.
kinetic?
Yes.
And they
So
gain kinetic energy, right?
yes. So they are heavily cross-linked polymers. So that is why we call them as thermosetting plastic. So for example, you have melamine or basically your electrical switches that you use. Okay, that's mainly made out of bakelite. Okay, so
Mm.
bakelite is used for making these kind of switches. And when you talk about tiles of the floor, so they use melamine for it. So
Yeah.
these actually are formed by thermosetting the plastic, where once you form this, or once you actually manufacture these kind of plastics, it cannot be softened again to make something else out of it.
Okay.
Okay, so that's basically the idea here, to use this kind of what you say material. Now in electrical switches sometimes there is a chance of a short circuit which might produce large amount of heat. Now instead of using a thermosetting plastic, if you use thermoplastic, it can just melt away and can cause a
Okay.
larger damage. So that's the reason we use thermosetting plastics for making electrical switches. Understood?
Yeah.
Yes.
Yeah.
Now, next coming to the recycling part of plastic, that's very important because what happens is if you do not recycle plastic at the correct time, so then what happens is they degrade to such an extent that they get mixed with other chemicals or materials and becomes increasingly difficult to recycle, and that may also lead to a kind of pollution. Okay, so that's the
Yes.
reason we call it as they are non biodegradable, and they do not get decomposed by microbial action. So microbes cannot act on plastics and make it, more decomposed or something like that. So that's the reason he says to avoid this, it's important to use biopolymers or biodegradable polymers, okay, which can again be recycled, can be used. Okay. But then again, there are several disadvantages of using plastics as well, because basically they are poor conductors of heat and poor conductors of electricity as well. Because extensive heating, plastic can get damaged. Even electricity sometimes, due to excessive load, can produce a huge amount of heat, which can cause damage to the plastic. Another
Okay.
advantage with plastic that we have is it can be molded very easily into various different kinds of shapes. Okay, which acts to our advantage again. Okay, and they don't get corroded like uh, metals, for example. At the same time, plastics can be resistant to different kinds of chemicals as well. So if you use something metallic, there is a chance of getting rusted or getting corroded. But in plastics, you have an advantage where the corrosion and rusting part can be completely negated because of the base material that it uses. Okay.
Yeah.
So now when we talk about polymers, so what exactly the polymers are? What does it mean basically?
Many parts.
So yeah. So the word poly itself says many. Okay. So here the term polymer can be defined as very large molecules having higher molecular mass. Okay.
Okay.
So from micro substances, you get a macromolecule, or from micromolecules, you get a macromolecule. And what exactly is happening here is these are formed by joining repeated structural units. The same structural unit is time and again repeated to get a particular form. Okay.
Yeah.
So then these structural units basically individually can be called as a monomer, and when linked to each other by covalent bond and taking the process forward, that can actually form polymers. So monomers can give rise to polymers, okay, through a process called polymerization. Understood?
Yes.
So single unit is a monomer, and then you have multiple units joined to each other by covalent bond formations, then
Yes.
it becomes a polymer. Okay. Now, when you talk about polymers again, there's several or many different ways of classifying polymers. Now, how can you classify? It is this classification can be based upon some special considerations, like how. So, one common way of classifying a polymer can be from the source we get it from. Okay, so
Okay.
basically three categories. The first one we can call it as natural polymers. Then second we have semi-synthetic polymers. So,
Semi-synthetic.
yes, synthetic is the term used for something which is artificially made.
Would that
Okay.
technically be like PVC stuff or like nylon?
Yeah, but nylon is completely a synthetic. It cannot be called semi-synthetic. I'll
Oh,
tell you the difference as well. So first one I said it as natural polymers, then second semi-synthetic polymers, and the third one is synthetic polymers. So what is the basic difference between these three? Now when we say natural polymers, so they can be found naturally. Naturally found in what? Plants and animals, like proteins, starch, resins, rubber. These are all natural polymers.
proteins. Like, do you mean
Yes,
like the proteins that get made like in the body?
yes, which are found in plants and animals. Yes, those proteins are also classified under polymers because they form units of carbon hydrogen.
Oh, that makes
Okay,
sense.
yes. Now, when I say semi-synthetic polymers, so I'm using the word semi, so it can be half natural, half synthetic.
So what would be a half natural, half synthetic?
So, like something called cellulose acetate. Now, there are two things here. Cellulose is derived from a plant. Acetate is synthetically made.
Oh,
Yeah, so that's the reason I can classify cellulose acetate, which is nothing but rayon, which is an artificial fiber again. Okay, yeah. So I can classify this as a semi-synthetic polymer because here I have two substances. I mean, a substance rayon, biologically called as scientifically called as cellulose acetate. So cellulose is derived from the plant. Acetate can be synthetically made. So that's the reason this can be classified under semi-synthetic polymers. Then what about completely synthetic polymers? Okay, for example, polythene, a plastic. Okay, so
okay.
synthetic polymers, yes, there are many examples for like plastic, which you can also call as polythene. Okay,
Poly.
there is no natural substance found in this. It's
Okay, so
completely
it's just
a
fake.
synthetic polymer. Yes, and even nylon, for example. Okay,
Yeah,
nylon.
because the
Yeah,
nylon just made out of like two solutions.
yes. Okay,
Okay.
so these are man-made polymers, and at the same time, they're extensively used as well. Okay,
So
so this
is
is how. Yeah.
synthetic much more used than like natural polymers?
Now that again depends on like where do you want to use it? Okay.
But wouldn't it make sense if synthetic would be used like more because that can just continuously be
Yes,
produced?
indeed. And in today's life, yes, a lot of synthetic fibers are being used. Of a lot of synthetic polymers are being used because it is easy to manufacture on a large scale, and at the same time, it is cost efficient. Natural fibers are quite expensive, quite expensive. Okay, because they have to be obtained from plant completely. So
So no
obviously
like hybrid or anything or like that.
No, even if it is a hybrid, as long as it is completely natural, then it's obviously going to be expensive because the
Oh,
cost efficient. There's no cost efficiency there. It takes a
oh.
lot of effort to get natural products. Whereas artificial ones, they can be produced at a very low cost. Okay, and that's the reason they are very cost efficient and cheap in the markets as well. That's why many of them do use even most of the fibers or most of the garment that we use in today's life are 90% what is it,
Yeah, you
synthetic
told me about
polymers.
this a while ago about like the cotton and silk and stuff like that.
Exactly.
Yeah.
Yes. Okay. So
Okay.
that's the basic difference here. And now, once after the classification of polymers, so what exactly are polymers again? Okay. So as I said, monomer units put together, they can be called as
A polymer.
polymers. Okay. So addition or chain growth. Now, here when we talk about polymerization reactions, that is what is going to be the next topic. So here is where you'll be learning about addition polymerization as well. Okay. So the addition or chain growth polymerization and condensation or step growth polymerization. So here is where you're going to add up something. Okay.
So is
Yeah.
that like in like PVC, the chemical
Hmm.
formula is like
Hmm.
carbon double bond and then there's like three
Yes,
hydrogens and
absolutely.
one chlorine.
Yes.
Oh, why is there only one chlorine? I drew it as
One.
like four chlorines and then yeah, whoopsies. But
Okay.
okay. And then in like polypropane, that just has like one additional like whole new branch of like carbon and then three hydrogens around it.
Hmm.
And then Teflon just has like four fluorines. That like how are you supposed to know that?
Supposed to know what? It's structure or what?
Yeah, like in PVC. Actually, no, never mind. I think I
Okay.
know. Yeah, never mind.
Have
Yeah,
you
I
seen
think
the structures?
yes, I'm looking at them right now and they're yeah.
Okay. So
Okay.
here when you talk about Teflon, for example, you can see four carbons are aligned or they are bonded with two carbons. Okay. And if the same multiple chain goes on, then what happens here is you get, huge amount of, what you say, structure of Teflon. So what basically Teflon is nothing but it's a repeating unit or a repeated unit of tetrafluoroethylene. Okay.
Oh,
So
yeah.
carbon atoms here would be linked to each fluorine atom, okay, which is again bonded to a carbon atom. As you can see, if the structure is right in front of you, you can actually get to know that how exactly it looks. So now coming to this polymerization addition reactions. So in this, what he says here is in this type of polymerization, where we call it as addition polymerization. Let's see what exactly happens. So, a variety of alkenes or dienes and the derivatives are polymerized in the presence of a free radical generating initiator. Like a catalyst can be used here. Catalyst, like benzoyl peroxide or acetyl peroxide. Okay. So, here the polymerization of ethene, for example, if it's taken, okay, with a small amount of benzoyl peroxide initiator. So here what is happening here is to ethene that is already existing, I am going to add phenyl, what is it? Not phenyl, sorry, benzoyl peroxide initiator. So there is
Oh,
some addition going on here. So that's the reason we call it as addition polymerization.
yeah. So you just
So
add minus and substitute.
exactly. Okay.
Well, how do you know where to? Like, I'm guessing like there's obviously a structure to like where you're supposed to add it in. Like in polypropane, like does it matter where you add that extra carbon and three hydrogens? Because if you add it like, because at the moment the structure would be on like the left hand bottom.
Huh?
Like, if you like move it to like the right hand top, would that not change the entire structure?
Yeah, absolutely. It would
How do you
change.
know where to put it?
No, but for that you need to study the structure of it all. Absolutely.
Oh,
Okay, you can't just like pull it out from the air saying that okay, this is going to be Teflon. No, you need to study the
so do you
structure of
think
it.
it'll be given to us, or do you think we'd have to figure that out?
You need to study it first, and then obviously you'll be able to figure it out.
Okay.
Yeah,
I don't know what I'm supposed to study? Like, okay, structure. So
yeah,
do
the
I just like
structure.
revise on every single like
Yes,
uh
absolutely. Yes.
so there's no
See,
like logic behind this?
no.
Oh,
Now, for example, see, logics do come into play for things like if I ask you to now write the structure of cyclohexane, I don't think you'll take much time to write it because yes, how you did study the logic, you studied that. But here, to write a Teflon structure, you obviously have to learn the structure there first of all.
okay.
Yeah.
In like PVC, right? Because
Yeah.
in polypropylene and then the Teflon, right? They both end with an "ene," so you know that it's like a double bond.
Yes,
But then
that's
in
it.
PVC,
Uh-huh.
it's just polyvinyl chloride.
Yeah, polyvinyl chloride. So you
So then,
have three hydrogens and one chlorine attached in
yes,
one
but how do you
particular.
know that it's a
Yes.
double bond?
How it is? There are no double bonds. They're all single bonds.
Isn't
Yeah,
the carbon
yeah.
carbon?
Yes, between the two carbons, you do have a double bond there.
So
Yes.
how would you identify that? Because in polypropylene it ends with an "ene," so you would be able to tell.
Oh, no, 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 no. Here, now it's a double bond. What are we calling it as? Aisle, vinyl. Did you
What?
get that?
It doesn't sound like "ene."
No, it's vinyl, aisle, alkyl.
Isn't it
Okay.
alkane, alkene, and alkyne?
So now, even if you talk about PVC now, for example, here we have a dipole-dipole interaction between those two. Okay,
Yes.
and you have an electrostatic attraction of a chlorine atom in one molecule to one with that of a hydrogen. Okay,
Yes.
exactly the same thing. So two
Okay.
basic forms. So PVC basically comes in two forms. One is vinyl chloride, the other is polyvinyl chloride. When in vinyl chloride, you have an existing double bond between two carbons. But in polyvinyl chloride, there's only a single bond existing between the two carbons.
What's
Okay.
the difference?
So, because when you say polyvinyl chloride, it is a huge long chain. That's the reason I use the word poly. Poly means more.
Yeah.
So, when I say only vinyl chloride, you only have one structure, okay, of vinyl chloride. That's it. So, the difference between poly and vinyl is only the number of such units. If I join multiple units of vinyl chloride to one another, then that
Then it
becomes
would
a
become poly.
polyvinyl chloride.
Oh, okay.
Understood. Now the same thing can happen with even what did you say again? Poly, propane?
Polypropylene.
Yeah,
Yeah.
propene or propane? Propene
Propene.
structure.
Yeah.
So what is
So
a
just because there's many,
yes?
that's why.
So here
Oh,
what do you have is the structure of CH2, CH and CH3 in polypropene. So basically it is propene. Understood? Basically it's a propene when you talk about polypropene. So why are we using the word poly here? When
because
you
there's
have yes, when you have multiple units of this attached to one another,
add
then it
poly
becomes
then
a
to anywhere.
poly. Exactly.
Ah, okay.
Understood? So difference between propene and polypropene is nothing. Propene is only a single unit. When you have multiple units attached to it, then
You
that
just add
becomes
poly.
exactly. So polypropene, basically they come from group of polyolefins. Okay. And
Okay.
if you look at its properties also, they are almost like more or less similar to that of polyethylene.
Okay.
Understood? Yes. But polypropylene or polypropylene, for example, they basically are slightly harder and more heat resistant. Okay, so that's the basic difference here.
I'm be honest, we're probably gonna have to go through intermolecular forces once more.
Yes, we need to.
Yeah. I kind of forgot all of my intermolecular forces from year 11. I thought that
Now,
we'd never have to look back.
okay. Now coming to this classification based on structure of polymers, even here we have three different kinds. One is a linear polymer. Now, when I say linear polymer, they basically consist of long and straight chains.
Yeah.
Yes. Okay. So these are more high density polythene. Polyvinyl chloride also comes under linear polymers. Okay. Then we have the next one called as branched chain polymers. So
Yeah.
along with the linear ones, you have some branch chains. You must have seen the structural formula also. When we write this, I mean the IUPAC name, you branch it here and there, depending on whatever the requirement is, so that you can
Mm-hmm.
actually connect to this. Yes, and sometimes you'll be having cross-linked or network polymers. So these generally form from bifunctional and trifunctional monomers. So, like for example, I used the name Bakelite a while ago. So bakelite, melamine, which are used for making floor tiles, they come under this cross-linked or network polymers.
Is
Okay,
that because
that's
it's
one.
like not
Yes,
very solid?
yeah.
So what is it called again? So it's
Cross-linked or network polymers.
cross-linked or network.
Yes, cross-linked or network polymers.
Is that when
Use.
it's like not a solid?
Now these are solid, of course.
I mean, it's a solid, but like in linear polymers, like they're all just straight and they're all very like
Yes,
heavily
yes,
structured. But
yes.
in cross-linked or network polymers, does that mean like
They're basically more hard and more tough. Okay.
would it be like a paste?
No,
No. Okay.
no, not at all.
Hard and more tough.
Hmm.
And this one would probably be like the toughest one out of all three of them.
So which one? The cross-linked one?
Mm-hmm.
Yes, of course.
Is that because of intermolecular forces between them or something?
Yes, yes. Because what happens in cross-linked or network polymers is they, first of all, they are formed from trifunctional monomers and they contain strong covalent bonds. So
Oh,
many, so what is exactly basically happening here is many linear polymer chains are put together to form a cross-linked or network polymer.
okay.
Understood? So if I
Mm-hmm.
take a long, what do you say, a linear polymer, okay, and then have multiple linear polymer chains, then I put it together, then that becomes a cross-linked or network polymers.
Okay.
So that is how actually it's formed. Okay. Now when I speak about polymerization, as I said, it can be classified on the basis of mode of polymerization into two subgroups. One is addition polymerization, the second one is condensation polymerization. Now when I say addition, the word itself is saying addition, to add up. Okay, so how are these addition polymers formed? So these are basically formed by the repeated addition of monomer molecules. So
Yeah.
single units of polymers, okay, when they undergo repeated addition, so possessing double or triple bonds, the formation of polythene, for example, from ethene, and polypropene for propene. Just now you are mentioning polypropene, polypropene, right? So what is polypropene? So basically, I have a propene, what is a molecule. To that, if I keep adding multiple propene units, then that becomes polypropene. So how did I put up multiple units? It's nothing by the process of addition.
Yes.
So when I call it as a single monomer structure, I can call it as homopolymer. Okay. When I have, I mean, what is it, units added to it, then we are
Um,
going to call it as like what do
ethene.
you say? Propene becomes polypropene or ethene becomes
Do they just
polythene.
add like more like the
Yes,
dashes into
yes,
it
yeah,
on the
exactly. So polymers here are made by addition. I mean, here in this case, made by addition polymerization from two different monomers also can be called as copolymers. Here, instead of just using what do you say, one kind of a monomer and adding them together, I can
Mhm.
even take two different kinds of monomers, and when I put them together, they can form copolymers.
Yes.
This is another one. Okay, so this is called as addition polymerization or addition polymers.
The one like with, I don't know, I can't remember, but it's like one like polymer or something, like they go across each other and then they, I don't know. It like goes,
That might be cross-linked.
yeah, is it like cross-linked where like they go across instead of like going in a line? Yeah,
Yeah,
like go
yes,
across to like connect. Okay.
exactly. Cross-linked or network polymers.
Okay,
Okay.
that makes sense.
So next is condensation polymers. So here, condensation polymers are formed by repeated condensation reaction between two different bifunctional or trifunctional monomer units. So what is saying, we are removing something from this. So in these reactions, the elimination of small molecules such as water, if you remove, or if you're removing alcohol, or you remove hydrogen chloride, for example, then it forms some other substance. Like for example, if I talk about terylene, okay, which is nothing but dacron as well. Okay, so if I take a nylon 6,6 for example, it's formed by condensation of hexamethylene diamine. Okay, now that's sound a little bit more, confusing to
Massive.
remember. Yes, but when I say hexamethylene, try to understand. Hexa is what's when do we
Six?
use the word hexa?
Six, isn't it six?
Six, exactly. Hexamethylene. So
Yes, draw the
six
bracket.
six methylenes with a diamine. So you're taking an amine. So NH2, for example. So two NH2s, and to
Yes.
this we're going to add adipic acid. So when hexamethyl diamine and adipic acid are combined, then it forms nylon.
Yeah,
Yeah.
that's deep.
So, and then during this, what happens here is, in this entire process, it's just not these two substances quietly combined.
No, you
But
don't.
when
You have to you have to combine it at a specific angle for it to actually like
that that that
form.
happens by itself, we did not do anything to that. Okay, that these chemicals do align themselves in that way. But during this entire process of forming this nylon, it also loses a water molecule.
So is that why it just layers upon each other like oil and water?
Yes.
Oh, okay. Yep, got that.
Understood till here?
Yes.
Yes. So tomorrow I'll teach you about elastomers in polymers itself, in fibers, thermoplastic polymers, thermosetting polymers in depth. Then again in this you have addition and subtraction reactions. Okay, so
I will do that. In our assignment, right?